with this example, they want us to solve this, and like I had mentioned, this 2x is kind of what throws things off a little bit. It's got two trig expressions, so I cannot isolate it. So what I'm going to have to do is use the formulas and tell me what is sine of 2x. Yes, if I go to my formulas, the double angle formula, sine is equal to, sine of 2 theta is equal to 2 sine cosine of theta. Now, on your assignment, you may have to replace cosine of 2 theta, but you may have three choices. It just depends on the problem. Remember, the problem or the goal is to eventually get one single trig identity, not identity, but one single trig expression. So you may want to use one that eventually gets you one, either cosine, sine, or whatever it is the problem is. So let's, in this case, it's not asking for cosine, but let's just use sine of 2 theta, 2 sine cosine, and let's write that in. So sine of 2x, I'm going to rewrite as 2 sine of x, not theta, because that's the variable they're using, cosine of x, plus cosine of x, that's this one, and then equals 0. Now, what does this term and this term have in common? So let's go ahead and factor out the common term, cosine of x. So I'm going to have cosine of x times 2 sine of x plus 1 is equivalent to 0. Now, using the zero product property, if I have two things that are being multiplied and equal 0, that means that cosine of x could equal 0. 2 sine of x plus 1 is equal to 0. And then just solve each one. If I do this as an over 1, is there a special right triangle for this problem right here? No. Because if I try sketching this, I cannot have a side of a triangle be 0. And, I have 1 down here, so just be careful with that. So no special right triangle, so instead I have to look at the graph. So sketch cosine of x graph. And remember that that's the one that starts off where? Right, so it starts off over here, then goes down here. These are the key points. Now be careful, this is where students get confused. Sometimes they may ask you what is cosine of 0 versus what is the x value when y is equal to 0, or when the value is equal to 0. So this one, notice this is what we're looking for. This right here is my y value. So again, here's the x, here's the y. So when I'm solving this, I'm trying to figure out what is the x value when y is equal to 0. Remember, on your graph, this is y, this is x. So if I go to this graph, where is cosine or the y value equal to 0? At pi over 2, and what's this? Yeah, don't forget your markers. Remember, this is 2 pi, this one is pi, this one is pi over 2, and this is the 3 pi over 2, which again, I'm interested in these two right here. So my answer on this side of the problem is going to be that x is equivalent to pi over 2 plus the 2 pi n, and x is also equal to 3 pi over 2 plus 2 pi n. And again, I've kind of done only one side of this problem right here. Now I have to evaluate this one right here, or solve for sine of x. Remember, I had to isolate this trig expression, sine of x. I move that over, becomes negative, and then I'm going to have to divide by 2. So it's like I have sine of x is equal to negative 1 over 2. Is this a special right triangle? Yes, because I have sine is opposite over hypotenuse. These are labels for a right triangle. So I could take this approach where I draw the possible x locations. X could be here. X could be over here with the reference angle down here, here, or here. Let's create our right triangles. Let me zoom in on this since we don't need that other side. And labels are opposite 1, hypotenuse 2 on all these right triangles. Now, the last thing to recognize is, not the last thing, but one of the things to recognize is that the opposite for these has to be negative because of their downward location. And which ones do I eliminate? Which quadrants? Yeah, so 1 and 2 get eliminated. And if you want to make a note, why are they being eliminated? You can do so and kind of point to them and say, sine of x is equal to positive 1 over 2, not negative. What's the angle here? 30. Good. So the reference angle here are 30 degrees. And the last thing to do, remember what we've been doing, we start from the positive x-axis. I want to end up on this terminal side. So how many degrees is it if I start from here and end here? A 180 plus the 30 degrees. So x is equivalent to 210 degrees. And the other one would be starting from here. I need to end up over here. Positive rotates this way. So what was it? 300. 330. Sorry. All right. Now, when you're changing them back to radian, especially if you don't have a calculator, don't forget your multiples. For example, I know that pi, you should already be familiar, is 180 degrees. The multiples that I want you to be aware is pi over 3 is what? What's 180 divided by 3? 60. And pi over 6 is 30. So when I look at these answers, you want to think in terms of multiples or divisibility. 210 right here, is it divisible by 60? No, not without a remainder. So it's going to be 30. So how many 30s fit into, or 210, how many 30s fit into that? So 7. So it's going to be 7 of the 30s, which is pi over 6. So it's going to be 7 pi over 6. And again, that has to do with when you don't have a calculator. And this 330 is going to be how many? 11 of the pi over 6. Alright, so now the only thing, again, don't forget to make sure that you also give your answers the same way that we gave our answers over here. I would say x is equal to 7 pi over 6 plus 2 pi n. X is equal to 11 pi over 6 plus 2 pi n. I need to indicate on here somewhere that n is any integer, which I forgot to mention over here. Yes. So my answer would be this, 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 and this. And if you want to write it in set notation, that's fine. Or you could give all these answers right here. Alright, so just be careful with this type of problem. It kind of involves, this is kind of like an accumulation or comprehensive problem where, we started off with an equation. We had to use the formulas. We had to use chapter 4 to solve each of these. And 5.3 was, I showed you how to give that, all of the solutions, the plus 2 pi n. Alright, any questions?